Hello, everybody. For part two here of the semester exam review, we're going to take a look at the next batch of questions, 21 through 40. So we'll start with 21 right here on the screen. We're told that this original figure, number one, is reflected across the x-axis and then translated 4 units left. So we're going to flip this across the x-axis up to the top and then move it 4 units left. So now it's just a matter of look at all the pictures and see which ones actually do it. The reflection has to have the point facing downward after it gets flipped over, so we can throw B and C out. And then it has to move 4 units left, which if we look, it's going to put it into the negative side of the on the y-axis, or across to the left side of the y-axis. So the only one that matches up, it has to be A. For 22, we're given some vertices, and then we're told they're reflected across the y-axis and then reflected again across the x-axis to produce the image. So basically, which one of these shows that? As a reminder, reflection across the two axes is also rotation of 180 degrees. So we're basically looking for the one picture out of the three here where it shows that it's been turned around, and the only one that matches up has to be B. Same idea for 23. We're going to get into how transformations lead to congruency. So if you start thinking about it, any transformation that we do, reflection, rotation, or translation, has to create the same picture. It doesn't change their size or their orientation at all. So if we look at the 4 options underneath, notice that all 3 of A, B, and D put the plus sign and the 2 dots side by side in boxes to each other, which is not what our original picture shows. The only possibility is C, and it's exactly what you would expect. It was turned 90 degrees counterclockwise. So a correct answer has to be C. It's the only one that's congruent. All right, for 24, we're asked to prove that these two are congruent based off of the different vertices. So basically, we start checking all of these transformations. Remember, just like in the last problem, a rotation, a reflection, anything like that generates an idea that is congruent, generates pictures that match up. So if we start testing them all, we basically just need to see which of these compositions in the list here matches up to our numbers. So first thing, we take xy and turn it into yx. So we're just going to do A going to D. So 3, 1. According to A's answer, we're going to flip the numbers. So that's now 1, 3. And then we're going to reflect it. So it's going to become 1, -3, which that is not what point D is. So that doesn't work. According to B, we're going to do a reflection. So XY stays XY. That's not even a reflection, so that can't work. And then let's see, next up. For C, we're going to subtract 4 from Y. So that'll take it down to -1. Then we're going to subtract, from X. Then we're going to subtract 6 from Y, which would put it at -5. That doesn't work. D's the only answer left. It has to be correct, but just to be thorough, we're going to take the point xy, flip them, and change the sign of the y value. So 3, 1 would now become -1, 3. And then we're going to do a reflection, which changes the sign of the second number only, -1, -3, which is exactly what D is. You can check the other 3 the same way, but you know you're correct. It's got to be the last one. See, for 25, the triangle can be done with reflections, rotations, translations. Which of these triangles would coincide with it? That's the idea that reflection, rotation, translation create congruency. The only answer that works is the one that has the same exact measurements. And again, before somebody says it, figure is not drawn to scale. Clearly, the side that's 2 is not longer than the sides that are not. That just doesn't make sense. But the idea behind the question is to figure out that it has to be the one that's congruent with the same measurements. The picture is just not drawn that well. For 26 here, you're given this picture, a rotation of 90 degrees to create D, E, and F. You're asked which statement is true. Basically, this is, again, your congruency statements. So A, B, and C matching up to D, E, and F. we're just going to take a look at what has to be true. BC matching DE, that doesn't work. AB matching DF, that doesn't work. C matching E, that doesn't work. So A matching D, the only option left, and sure enough, that's the first letter in each one. Absolutely correct. For 27 here, we're looking to move these 3 points with the translation, adding 4 to x and subtracting 2 from y. So let's just list off the points here. They're not labeled in any way, so I'm just going to list the numbers. We've got a point that's at 1, 2, -3, +1. We've got a point that's at 0, +1. And then we've got a point that's at -1.5. And then up to 1, 2, 3, 4. All we're going to do for each one of these is add 4 to the x values. So that becomes 1, that becomes 4, and that becomes 2.5. And then subtract 2 from the y values. So -1, -1, and 2. Our new triangle after that translation has to sit at those 3 points. For 28, we've got a reflection that creates a triangle ABC turned into A, B, and C prime. Do the pre-image and image have the same size and shape? Well, again, for the third or fourth time in this last chunk of problems here, reflection is one of the changes that does create congruency. So we know it's a yes, which if you start looking across the list, B is the only one that says yes. You know it's got to be the correct answer. But if you read the rest of it, reflection preserves angle measurement and lengths of sides. Yeah, all it does is change the orientation of the picture from top to bottom or from left to right, but it still keeps the picture. It doesn't change its size or anything like that. For 29, we're given a couple of statements about 2 triangles, and you're asked which of these things is true. So we just start checking them all off. The easiest way to actually do this, though, would be to physically draw it. So if we draw a triangle, call it A, B, and C, and we draw a second one, call it D, E, and F, and we're just going to fill in what we know. A matches D, B matches E, and BC matches EF. Now we continue along here. The given information is enough to create side angle side. Well, if we start looking, we don't have a second side, so we can't use that. There's only one side listed. The given information matches angle side angle. I agree we've got 2 angles, but notice where the side is not listed there, so that's out. Angles C and F would also be congruent. That would be true. We could add that to the list here. So this wasn't originally in the problem, but this answer is adding it to it. And then based off that, we could do angle side angle, at which point we could. We have an angle, a side in the middle, and an angle, and it matches the other trios. C will end up being the correct answer. Now, as a side note to that one, while that's the correct answer based off of the ones that are available to you, you could have made your life a lot easier. You had 2 angles and a side not between them. You could just argue the triangles are congruent based off of angle, angle, side and be done. But that option's not provided in the 4 that are listed, so you have to actually build the 3rd angle. See, for 30, you're given 2 triangles that are congruent based off the pictures underneath them, and then you're asked which of the following are actually true. As with all which of questions, we just start reading them and testing them. So A, B, and C matches D, E, and F based on side angle side. Well, if you look at the first one here, there are no angles in that first one. So you cannot be using side angle side with that first triangle. It just doesn't fly. So the second one here, B, ABC going to DEF by side, side, side. That's believable. And then DEF to the other one by side angle side, which if you notice, that one's got side angle side in it. That's good to go. At which point you don't even have to check the other 2. Plus, the last part here, transitive property, that's kind of the logic. You're going from the first one to the second one, and then you're arguing the second one to the third one. That kind of screams out transitive property. You're going from 1 to 2 and 2 to 3. For 31 here, we're going to fill in some blanks in this proof. We are given that we have these two sets of parallel lines, as you see in the picture here, and the two givens are already labeled for us. The rest of it is on us to figure out. So angle BAC has to match up to DCA. That is a pair of alternate interior angles. But if we get down to line 4, ACB, which is this portion, matching up to CAD, which is this portion, that is a second pair of alternate interior angles, which shouldn't be a surprise. You had two givens with parallel, so you should get to use it twice, alternate interior angles both times. We can also argue the line in the middle, the diagonal, is congruent to itself. Anything congruent to itself is the reflexive property, at which point you have created two triangles that have two angles and a side between them matching up. This must be a pair of congruent triangles thanks to angle side angle congruency. 32, we're going to do another proof here, same idea, but a little bit bigger of a picture. So if we take a look here, we got to fill in the blanks in the given. The line 1's not complete. So BAC, which is the angle down here with the double mark, has to be matching up to DEC. Angle ABC, the single mark, so it has to be matching up to EDC. And then BC is the single side mark, so it has to be matching up to DC over here. All three of those are given because they're already drawn in the picture for us. At which point, these two triangles on the outside are congruent because you have two angles and a side not between them, angle, angle, side congruency. But because of that, we get to add things to the triangle in the middle now. AC is a congruent side to EC, thanks to the corresponding parts of triangles I just proved congruent, which now means triangle ACE is an isosceles triangle because it has two congruent sides, which now means its angles at the bottom, this one here and this one here, have to be congruent to each other because that's how the isosceles triangle works, literally the isosceles triangle theorem. If you have two sides that are congruent, the base angles across from them are also congruent. See, for 33, we're given this picture, and you're asked which of these statements should be used to end up proving that 1 and 5 add up to 180. Very literally, let's just test them. As with all multiple choice questions, which of multiple choice questions should always just be read the answers and test them? So let's see what we got. 1 and 8 are congruent based on being corresponding. 1 and 8 are corresponding, I agree. And then 5 and 8 form a linear pair, side by side, forming a straight line. Lucky us. First one right off the bat's 100% true. And since it didn't say to select all that apply, we don't have to go checking the others. But if you check them, you'll see why they don't work. See, for 34, we're given this isosceles triangle, and we're told that AB and BC match up, and that you have the angle bisectors drawn in as well, meeting at point X. So angle BAC, this whole entire thing, is 50 degrees. You're asked to figure out the measurement of AXC. This portion right here is what we don't know. So let's focus on it. Thanks to the fact that it's an isosceles triangle, I know I can move this 50 over here as well. And then I was told it's angle bisector, so I want to focus on just the small triangle at the bottom. 25 in this corner, 25 in this corner, and the one that I'm trying to solve. I'm literally zooming in on this bottom triangle down here. And I know they're 25s because I was told it's angle bisector. It's half of 50. At which point, this is a plain old triangle problem. 180 minus the 225s that I already know means my missing angle has to be 130 degrees. Let's see, for 35, we are given this picture, a pair of parallel lines, S is parallel to T, and you're asked to answer the following. C is congruent to which angles? And it does say select all that apply. So let's do this the easy way. Angle C is right here in the picture. There are four things it could match. It has a corresponding angle up here at F, which means I do want to take F as an answer. It has an alternate interior angle at B. I do want to take B as an answer. And it has a vertical angle right here, which is not listed as anything. So at which point I've done the whole problem. B and C are the only two on that list that work. For 36, we're given this figure and asked to go find the value of X and then the measurement of each angle. So since it is a set of parallel lines, we have a pair of consecutive angles, and according to the property, a pair of consecutive angles that are on the same side, like you see in this picture, have to be supplementary to each other. So X added to X minus 58 would have to be 180. We'll combine some like terms together, 2X minus 58 to be equal to 180. If we add the 58 over, 2X would be equal to 238, which then will cut that in half. So X will be equal to 119. That serves a double purpose. We had to find the value of X, but it is also the measurement of this angle since it was a single X listed for it, 119 degrees. If we subtract 58 off from it, we end up with this angle at the bottom being 61 degrees, and you can always double check your work. 119 and 61 do in fact add up to 180, so we're good to go. For 37, we're going to get this picture and then be asked to find the measurement of its angle. We're asked to find the measure of angle B in this isosceles triangle. So same idea with isosceles. Let's use the definition. We have the theorem that the angles across from the congruent sides have to be congruent, forcing a 62 degree to pop up here in A as well, at which point we have a plain old triangle. 180 minus the pair of 62s that we already know in the picture leaves me with 56 degrees for angle B. Which then for 38, we're asked for the length of KL, the entire thing. And you would think that that's a little difficult based off the picture, but all the congruency marks in red are very helpful. Since they are all coming onto midpoints and splitting the sides in half, we know we're dealing with median and centroid, which makes this problem very, very quick to solve. The top part, LP, has to be twice the length of the small part from P to K. That's the centroid property, the 2-to-1 ratio. So if we cut 27 in half, this has to be 13.5 for this portion from P to K, at which point adding them together makes the whole entire thing 40.5 units long. All those red marks is the sole reason that problem is solvable. See, for 39, we get a nice story about Luciana and Tanner driving off in different directions after lunch and whatnot. The key is the picture. Look at the picture and then answer the question. The picture shows that they went in two different directions, and you're asked, what's the possible range of values for D? This is basically asking you what's the maximum and the minimum that it could possibly be if you were forming a triangle out of these. Well, in case you don't remember it from back in the triangle inequality, the minimum is the difference. So we'll take 5 minus 3. At the absolute smallest, they could be 2 miles apart. And then the maximum is their sum. So we'll take 5 plus 3. You must have that these two people are somewhere between 2 and 8 miles apart from each other. Triangle inequality problems are nice and quick. And then last one here for 40, we're given another proof. However, this one is a multiple choice question. You're given this setup with the given and the proof here, and you're given that these statements are correct, but the reasons and whatnot are not in the correct order. So we need to actually put everything in order. Now, here's where we get into some logic of how are proofs built. Given should come first. We know that for a fact. So A's out and D's out. 3 has to come first. Now, if you look at the 2 remaining answers, they do line 2 next, line 5 next. The only difference between these 2 answers is 1 before 4 or 4 before 1. So 1 has angle, angle, side, while 4 has CP, CTC. The logic's the following. You can't have corresponding parts of congruent triangles. That's the key part there. Remember that the C and the T stand for congruent triangles. You can't have corresponding parts of congruent triangles if you didn't prove they were congruent first. The correct answer is B. You have to have angle, angle, side before the corresponding parts kick in. That's everything for the second part here. If there's any questions, make sure to ask your teacher, and see everybody in part 3.